Good morning, ma'am. This is Bhavya from the Department of Computer Science and Engineering, second year, and today I'm here to give a presentation PPT on normal distribution from the subject Probability and Statistics with the subject code 23 MAT09. So moving on to the next slide. What is normal distribution? A normal distribution is a bell-shaped curve where most values cluster around the mean, with fewer values appearing as they move further away. It is symmetric and its spread is determined by the standard deviation sigma. Therefore, z is equal to x minus mu upon sigma. So moving on to the next slide. What is the procedure for finding the normal distribution? The problem that the normal variate x with mean mu and standard deviation sigma lies between two specific values x1, x2 with x1 less than or equal to x2 can be obtained using area and the standard normal curve as follows. So the step 1 is perform the change of scale, that is z is equal to x minus mu upon sigma, and find z1 and z2 corresponding to the values of x1 and x2 respectively. Step 2 is to find p of x1 less than or equal to x, which is less than or equal to x2, which is equal to p of z1 less than or equal to z less than or equal to z2. So case 1 is if both z1 and z2 are positive or both are negative, then p of x1 less than or equal to x less than or equal to x2 is equal to mod of a of z2 minus a of z1. Here a is nothing but area. So area under the normal curve from 0 to z1, area under the normal curve from 0 to z2. Right. Moving on to the next slide. Case 2. If both z1 is less than 0 and z2 is greater than 0, then p of x1 less than or equal to x less than or equal to x2 is equal to a of z2 plus a of z1. So as we can see from the diagram, so B is to find p of z greater than z1. So case 1 is if z1 is greater than 0, then p of z is greater than z1, which is equal to 0.5 minus a of z1. So we can see it from the diagram. We have in the middle we have 0, and to the left hand side we have negative infinity, and to the right hand side we have the positive infinity. Right, so the case 2 is if z1 is less than 0, then p of z greater than z1 is equal to 0.5 plus a of z1. So if z is greater than 0, then we take the minus sign, and if z1 is less than 0, then we take the positive sign. Moving on to the next slide. So case 2, if z1 is less than or equal to 0, then p of z is less than z1, which is equal to 1 minus p of z is greater than z1, which is equal to 1 minus under the bracket 0.5 minus a of z1, which is equal to 0.5 plus a of z1. So here one point to be noted is area cannot be negative value. So a of minus z is equal to a of z, because area is a scalar quantity, so it cannot be negative. Now, here's the problem. For a normal distribution variant with mean 1 and standard deviation 3, find the probability that 3.43 is less than or equal to x, which is less than or equal to 6.19. And second question is minus 1.43 is less than or equal to x, which is less than or equal to 6.19. So moving on to the solution part. So given that mean or mu is equal to 1 and standard deviation sigma is equal to 3, probability we have to find, which we take as z. So here's the solution. I'll just be reading the solution because it has already been solved. When x is equal to 3.43, z is equal to x minus mu upon sigma. So which is equal to 3.43 minus 1 upon 3, which is equal to 0.81, which is z1. When x is equal to 6.19, then z is equal to x minus mu upon sigma, which is 6.19 minus 1 upon 3, which is equal to 1.73, that is z2. Therefore, p of x1 less than or equal to x, which is less than or equal to x2, is equal to p of z1 less than or equal to z less than or equal to z2, which is equal to under the modulus a of z2 minus a of z1. and when we solve it further, we get 0.4582 minus 0.2910, which is equal to 0.1672 as shown in the diagram. So moving on to the next slide. When x is equal to minus of 1.43, then z is equal to x minus mu upon sigma, which is equal to minus of 1.43 minus 1 upon 3, which is equal to negative 0.81, which we will be considering as z1. When x is equal to 6.19, z is equal to x minus mu upon sigma, which is 6.19 minus 1 upon 3, which is equal to 1.73. We'll be considering it as z2, and p is equal to x1 less than or equal to x, which is less than or equal to x2, which is equal to a of z2 plus a of z1, and upon solving it we get 0.4582 plus 0.2910, which is equal to 0.7492. So that was all. This was about the entire presentation on the topic normal distribution, and with this I conclude my presentation. So thank you everyone. Presentation by Bhavya Jha, bearing the roll number 234G1805525 from the Department of Computer Science and Technology. Thank you.